So we are taking the next theorem now, and that is theorem number 3. This theorem states that the radius is perpendicular to the tangent through the point of contact. The radius is perpendicular to the tangent through the point of contact. Now let's see the illustration. Let's see the illustration supporting that theorem. Okay, this is a circle, and here is the fixed point, and that is considered as the center. So here is a tangent, the straight line that touches the circle at one point. This is the tangent. Now, here is radius, the line drawn from the center to the circumference of a circle. Okay, so the law or theorem states that the radius is perpendicular to the tangent through the point of contact. So this is the point of contact, okay? Let's say this is center O, this is point A, this is point B, this is point C. I get it now. So this radius OB is perpendicular to this tangent AC. Okay? That line OB, which is the radius, is perpendicular to side AC, which is the tangent. So between the tangent and the radius, there is a right angle. The radius is perpendicular to the tangent through the point of, this is the point of contact B. The point the tangent touches the circle. That is where the relationship is established. That is where the relationship is established. The relationship between the tangent and the radius. So the radius is perpendicular to the tangent through their point of contact. That is theorem number 3. Now let's take the next theorem. Theorem number 4. Don't forget, I promised that in our subsequent episode, we shall begin the application. But there is need to understand those theorems before we begin the application, so that you can be able to comprehend easily. Now let's move on to theorem number 4. Theorem, I told you this topic is very simple, but so many candidates are fond of neglecting it. They see it as a topic that is very difficult, whereas it is simple. But ensure you don't miss any of my episodes on this topic, because I am going to make it very simple. I'm going to make it very, very simple for you to understand. Now let's move on to theorem number 4. Theorem number 4. This theorem states that the angles in the same segment of a circle are equal. The angles that are in the same segment. Now let's see what I'm talking about. Let's see, this is a circle, or this is a circle. This is a circle, and this is the fixed point, which is the center of the circle. Okay? Randomly, let's say this is point A on the circle, this is point B, this is another point, let's say point C, okay? Let's say this is another point, randomly, this is another point, point D. Are you getting that? Let's say this is another point, point E, this is another point, point F. So EF is a chord. EF is a chord that divides the circle into two unequal parts, or into two segments. So if I join side EC, so I'm trying to join the two. It is better now. Okay? Now let's not join point CF. Yes, this is CF. You can see there is an angle here subtended by C. There's an angle accommodated, subtended by C. Okay? Let's see another one. And let's join side AE, and also join side AF. You can see point A is also subtending another angle. Very good. Now let's see here. This is point B. So I want to join side EB and side BF. EB and BF. You can see point B is also subtending another angle. Okay, so you can see that this angle this angle and this angle. The three angles are subtended by the same chord. They are inside. The chord is EF. The chord is EF. So it is this chord that is accommodating this, and also accommodating this. So the three are in the same segment. Remember, the chord divides the circle into two segments. So this is one segment, the major, this other segment, the minor. So this angle, they are inside the same segment. They are inside the same segment. And the angles in the same segment of a circle are equal. So mathematically, let me illustrate it as, you see, angle ECD is equal to angle, you see, ECD, that is F. It is F. The chord is EF, okay? The chord is EF, so it is F. So angle ECF is equal to angle EAF. EAF. Are you following, class? That is good. Is equal to angle EBF. EBF. They are all in the same segment. So ECF, angle EAF, and the angle EBF. They are all inside the same segment. So they are subject to being equal. They are subject to being equal. So the angles in the same segment of a circle are equal. Let me give another illustration to, support the message of the theorem. Yes, you see. So now look at it here. Look at it here. So this is another circle. Okay. So this is the chord. Okay, let me call it AB, chord AB. Okay, so this is and let's say this is point C. Okay, and let me join side B, C, and let's say this is another point D. So I want to join side A, D, and side B, D. So you can see that the angle here and the angle here, the two are in the same segment. So the chord is AB. So angle ACB, that's angle ACB is equal to angle ADB. Angle ADB. Reason is, see, it is very important. By the time we begin the application, so there is need to always give reason to any value you equate to. So to whatever you equate to, you have to support with reason. It is very, very important. It's very, very important. Without the reason, you will not get the whole mark that is allotted to such a question.